we are ready now to discuss the structure of the PMOS transistor. The PMOS transistor is similar to the NMOS transistor with few differences. If this is the substrate of the PMOS transistor, then the substrate, which is the body or the bulk, is made of N-type material. Remember that in the NMOS is made of P-type material and the PMOS is made of N-type material. So it is made here for the PMOS of N-type material. Then we have the source and the drain, and the source and the drain are made of heavily doped P+ type material. Then for the gate we're going to have silicon dioxide and the poly layers to constitute the gate. So we can state that as in the NMOS there is a silicon dioxide layer and a poly layer at the gate. In fact, that for the CMOS technology, because both NMOS and PMOS are built on the same wafer, we have the same layer of polysilicon and the silicon dioxide for both transistors. Finally, the body of the PMOS is usually connected to the highest voltage in the circuit. So as you see in the animation here, we have heavily doped N-type material that is connected to the body, and the body of the PMOS transistor is connected to the highest voltage in the circuit. We are ready now to discuss CMOS technology. So remember that in CMOS technology we said that both NMOS and PMOS transistors are built on the same wafer. Wafer means the main substrate or the main body or the bulk of the integrated circuit, and it is usually made of P-type material. Current state-of-the-art manufacturing process use P-type material for the bulk to manufacture CMOS technology. Usually NMOS transistors are built on the main substrate, and the PMOS transistors require a well or a top of N-type material. So what that means is we come to the main substrate and we create a top. So now we are ready to build NMOS and PMOS transistors on the same wafer. So let's show you animation of how this is done. So we start with the substrate, the main substrate or the wafer, that is the bulk of the integrated circuit. And the first thing we will do is we will create N well for the PMOS transistor. Once we create the N well for the PMOS transistor, now we can build NMOS on the main substrate and a PMOS on the N well. So we will start with the NMOS, and what we will do is we will diffuse the heavily doped N+ material to represent the source and the drain, and then we will have the layer of the silicon dioxide and the layer of the polysilicon to represent the gate. The body has a contact with a P+ type material that is connected to the lowest voltage in the circuit, that is usually ground. For some analog circuits that can be negative voltage. So the body of the substrate is connected to the lowest voltage of this integrated circuit. You do the same thing for the PMOS, so we diffuse the heavily doped P-type material to represent the source and the drain. Then we have the silicon dioxide and the poly to represent the gate, and for the bulk we use heavily doped N-type material connected to the body, and the body for the PMOS transistor is connected to the highest voltage in the circuit. So now we end up using the same wafer to develop an NMOS and a PMOS transistors, which means a CMOS technology.